Hello! Welcome to this tutorial where I'm going to talk about memory management. In this tutorial, we're going to dive deep into the fundamentals of memory management in programming. And by the end of this tutorial, I'm hoping that you'll have a solid understanding of key memory management concepts and how they apply in practical coding scenarios. Before anything else, let me introduce myself. I am J. Carlo de Mapilis. I am currently a first-year student in Gordon College, pursuing a Bachelor of Science in Computer Science. Just like you, I'm intrigued by memory management, mainly because of its crucial role in efficient programming. So, before watching this video, you might be wondering, what is memory management? Well, that's why I'm here to teach you about memory management, and we'll learn it together.
What is memory management? Well, memory management refers to the process of controlling and coordinating computer memory, which is essential for the proper functioning of software and the operating system. Memory management's primary goal is to allocate memory space efficiently among multiple processes, ensuring they have adequate memory to execute while preventing conflicts and maximizing overall system performance. Well, that's pretty educational, but what are its uses? You're in luck, because I'm gonna show you some of its uses. First off, we got resource allocation, allocating memory to processes and programs as needed. Memory protection, preventing unauthorized access to memory areas, ensuring data integrity and security. Optimization, maximizing available memory and minimizing fragmentation to enhance system performance. And we also have virtual memory, providing an illusion of more extensive memory than physically available through techniques like paging or swapping. How is it used? In practical terms, memory management is handled by the operating system. Programmers interact with memory management through programming languages, libraries, and APIs. They request memory allocation for variables, data structures, or objects when writing code. The operating system then manages these requests, allocating and deallocating memory as necessary. Memory management in programming involves allocating, using, and freeing memory efficiently. The functions malloc, free, and realloc are commonly used in C and C++ for memory allocation and deallocation. First off is the malloc. Malloc stands for memory allocation. This dynamically allocates a specific amount of memory during runtime. The general syntax is the void parenthesis malloc size t size, where the size is the number of bytes to allocate. Free deallocates the memory previously allocated by malloc, calloc, or realloc. The syntax is void free parenthesis void asterisk ptr, where ptr is the pointer to the memory block to be freed. Last one is realloc. Realloc changes the size of memory block previously allocated by malloc, calloc, or realloc. The syntax is void realloc, void asterisk ptr size t size, where ptr is the pointer to the previously allocated memory block and size is the new size. The end variable lets me allocate the memory. The pointer variable is to store the address of allocated memory. N into the size of n is the memory required to store n number of integer values. The allocated memory to the ptr variable stores the address of the first byte of the allocated memory, and we can use the ptr variable to access the remaining bytes as well. The ptr is the pointer variable that stores the address of the memory allocated using malloc. Allocated spaces for 4 element and ptr stores the address of the first element, so we can treat ptr as an array. Parenthesis ptr plus I gives the value pointed by the ptr plus I pointer while working with malloc. There might be situation where the memory allocation fails. In such situation, the malloc function returns null. So we have the if condition. And last, we will add the free function. If the malloc function returns null, then condition becomes true and the memory cannot be allocated. So that's why we use free function to release the allocated memory. And we run this code. And as you can see, we have allocated the memory. If we needed to store two more integer data, we could use the realloc function to change the size of dynamically allocated memory. So I'll be removing this part of the code to take input values. And then I'll add the new value of n with value 6. Let's run this code and we can see that the output here, initially 4 spaces were allocated using the malloc, and then we increased the size from 4 to 6 using realloc.
So to wrap up, we've covered crucial concepts in memory management: allocation, deallocation, and dynamic array resizing. Remember, efficient memory management is key to writing robust and optimized code. Thank you for joining me in this tutorial. I hope it provided valuable insights into memory management. For further learning, check out the resources in the description, and feel free to explore more about memory management techniques and best practices. That's all for today. See you.